How do prisms appear in nature and geometry? Have you ever noticed how certain shapes seem to pop up everywhere in nature? One of those shapes is the prism. So, how do prisms appear both in nature and geometry? Let's break it down. A prism is a three-dimensional shape that has two identical, parallel polygonal bases connected by rectangular sides. The bases can be any polygon, like triangles, rectangles, or hexagons. For instance, a triangular prism has triangular bases, while a hexagonal prism has hexagonal bases. In geometry, we study prisms as solid shapes defined by their faces, edges, and vertices. Each prism has two congruent bases and rectangular side faces. The number of edges in a prism is 3 times the number of sides of its base polygon. For example, a hexagonal prism has faces, 18 edges, and 12 vertices. Now, let's look at how prisms show up in nature. One of the most fascinating examples is honeycombs. The cells in a honeycomb are hexagonal prisms. Bees create these hexagonal tubes because this shape uses space very efficiently. It requires less building material while maximizing storage volume for honey. Another great example is crystals. Many crystals, like quartz and salt, naturally form prism-like shapes. These shapes come from the atomic structure and bonding patterns within the crystal. The flat rectangular sides and polygonal bases are a result of how the atoms arrange themselves. You can also find prism-like structures in some plants and minerals. Certain ice formations exhibit these shapes due to growth patterns that favor repeated polygonal cross-sections extended in one direction. Understanding prisms in geometry helps explain why these shapes appear in nature. Their uniformity and symmetry provide strength and efficiency. This is why nature often opts for these forms. From a geometric perspective, studying prisms involves calculating their volume, which is the area of the base multiplied by the height. This is important in fields like architecture and biology. Prisms are fundamental three-dimensional shapes defined by parallel polygonal bases connected by rectangles. In nature, they appear in structures like honeycombs and crystals because their shapes offer practical advantages such as space efficiency and structural integrity. This connection between geometry and natural forms helps us appreciate the world around us.